After 3 years of time, after 2,100 hours of work, after 18,000 rivets and 38,000 holes, 400 feet of wire and 3 gallons of paint, November 229er Romeo Victor is finally ready to pull out, fire up, and be flown. And on July 22nd, 1995, we did just that. The video you're about to watch is a systems tape. Now what we mean by systems tape is we're going to walk you through step by step, or as good a step by step as we can do, on how we installed the systems in our airplane. And what we mean by systems is the fuel system, the oil system, the instrument system, the radio systems. As for all of our tapes, this tape is strictly for entertainment purposes only. Is not a reference material and is not an absolute how-to, but just how we installed ours. Now, before you get started, there is some reference material that you may find very helpful to get before you start this process. The first one would be the FAA AC 43.13-1A, Acceptable Methods, Techniques, and Practices, and AC 43.13-2A, Aircraft Alterations. This book will show you a lot of techniques that are used in building airplanes. Another good reference material is Aero Connection by Bob Knuckles. EAA Technical Advisors is a good source for help on doing some of these things. Local A&Ps, other builders, and even VANS aircraft or your particular aircraft manufacturer can sometimes give you some good advice on how to do these systems. Some things to think about even before you get started. Think ahead. Work slow. Think about what you're doing and how it will affect other things that you're going to be doing. When you're placing something, think of what it's going to interfere with. Think what it's going to relate to, so you're not putting things out of reach. A lot of this will pay off in the long run by not having to overdo things or remake parts, or just not coming up with a final product, a plane that you're really happy with. We start by putting the big parts on. Now what we mean by big parts is things that can only go in one place. We start with the alternator. Okay? Exhaust pipes. And people may not think this is important, but we've had a lot of people say exhaust pipes are the last thing they put on, and they find out it interferes with the way they've run their fuel lines or something. The heat muffs on the exhaust pipes, they can only go in one place. If you've got a constant speed prop, your prop governor, your vacuum pump. Hopefully by now you've got your carburetor and air box on. These are things that can't go in any other location, so you want to put those on first. The next thing we did was put the engine baffle on. Now, before you start, you want to think about what you're doing, and you really need to realize why you're doing it. Lycoming engines are air-cooled. The air comes in through the front, passes over the engine, down through the cooling fins. This is what keeps your engine cool. Now, the purpose of the baffle, the engine baffle, is to confine that airstream that's coming in through the front of the engine to just over top of the engine. So when you put your baffle in, you want it to be a nice tight fitting baffle. You don't want any more air to escape than possible, because you've not only got to cool your engine, you're going to have an oil cooler you need to supply air to. You're going to have blast tubes to cool your vacuum pump and your mags. So there's going to be a lot of air escaping from this baffle anyway. So you want to build your baffle as tight as possible. Now we start by putting the back of the baffle on and the sides of the baffle on. And then you've got to make those fit with your cowling. So it's not a bad job to do, but it's one of those jobs you got to take it step by step so you get it right. First we place the rear part of the baffle. Now there's a hump in the engine, and you've got to make sure it fits in there all right. We've also added the two rear side plates of the baffle. Now the kit from VANS comes with some little components, and what they are is little doubler plates that go on the side here, and there's an actual little full-size sheet. And the first thing to do is probably just sit down and cut those little doubler plates out. But that's where they go, right under the screws here, and they're riveted on. We've placed the baffle in here. Now remember I said you want a good fit. This baffle's a little big. You want the metal part of the baffle to be about 1/2 of an inch below your cowling. And when talking with VANS, they said, yeah, 1/2 inch, no more, no less, 1/2 inch. The reason for that is to give it a little room for the engine and all to shift without beating your cowling. That 1/2 inch will be later taken up with a rubber seal that goes in here. Now, how do we mark a 1/2 inch? Well, first you make yourself a marking tool, and all the marking tool is a sharp or a marker pen, and I've taken and cut a piece of aluminum. This is 1/4 inch aluminum, really just a 1-inch circle, and it fits, pull it off right on top of the pen. Now what this gives me is my 1/2 inch distance. I can run this along the top of the cowling and mark the cowlings here. I can mark along there, mark the aluminum, and I won't mark down any further than a 1/2 inch. Now, what I mean by marking is you actually take the top of the cowling and place it on. You want to do this with the bottom part of the cowling still on, okay? So, but what you'll do then is then reach inside the oil door and slide this pin along the top of the cowling, right along the contour of it, and you can mark that whole back baffle. You can get almost all the way across, okay? Then to get the other side, you can actually reach in through the right-hand side and reach all the way to the back and mark that, okay? Then what we're going to do is take the cowling off, and we'll have this very nice mark that goes all the way along the baffle here. We'll take the baffle off and we'll trim it to that mark. Now your first couple trims probably won't fit. You're still going to have a lot of material there. But with the bottom part of the cowling on, put the top part on, mark it again. Eventually you'll get down to where you're not going to mark anymore, because your pin is going to be a 1/2 inch from the top, from underneath your cowling, and that's all it's going to mark is right there on the aluminum. So that's how you mark that. So you get your rear baffle done just the way you want it, marked and trimmed, and if you can see this one, it follows the contour of the cowling real nice right in there. And that was just sliding, actually using the cowling as the template. The next thing you want to do is your side plates. Now, the left-hand side plate is going to be easy to mark. Those are the lower cylinders. You can actually reach in through the left-hand side opening in the cowling and mark that left-hand side. The right side's a little more of a problem. So what we do is we take this rear baffle plate off, put the whole forward side on, and then we can reach in through the oil door and mark this place. And it's a little tight, but you can just reach in there, again, mark right along the cowling using the top of the cowling as your template or as your guide. Now with the forward part of your baffling done, now it's time to start to do a little thinking. This is going to be something you want to think about later, and that's going to be your oil cooler. Now there's a couple different choices about the oil cooler. One you can mount in the front on the left-hand side, you can mount on the rear of the left-hand side, you can mount on the firewall, and we'll get to those choices here, but you want to start thinking about things like that. Front's on. Now we want to start to work on this forward part here that'll start to form your chute on where your baffle will go. Start with the right-hand front deck. There's a couple features of this. One, if you've got a constant speed prop, your oil line is right here, and there's a hole that goes right through this that allows the oil line to go through. There's also a doubler plate in here that you want to put on, and that just stiffens up this area. Once you get this all put on, you're going to want to seal that hole off, and what we do is take a little bit of the rubber baffle that comes with the kit and actually make a little patch, cut a hole in it, and we'll just use some Pro Seal or RTV to just glue that little patch on, but you want to seal that hole. So anyway, to get this to fit takes a little work. It's a little long, especially if you've got a constant speed cowling. These baffles are made for fixed pitch prop cowlings, which are a little bit longer. So you want to just trim it back, trim it back. Again, you want a ½ inch clearance between your fiberglass and your aluminum here. And the reason for that is so you can get your cowling off. Now, that clearance will be sealed with a rubber seal eventually. But for right now, you want to put that on. If you're using a constant speed, you have to re-bend this. There's two bends here. There's a bend here and a bend here, and these bend lines are marked, and it tells you constant speed or fixed pitch. Also, something you want to think about in this area is your alternator cooling. And you can see right here we've got a little circle and a thing that says ALT, alternator. We'll probably put our alternator cooling tube right in there. And these are things you just want to mark now. So anyway, this is in place. Then we come around to the left-hand side. On the left-hand side, you've got this, and again, it's held in. There's a piece of angle here. There's another piece of angle that runs down the side that attaches it to the side plates. There's some pieces underneath, and we'll have to take the cowling off to show you the underneath pieces here shortly. But again, here's a place where you could put your oil cooler. If you're going to do that, however, you don't want to put this second bend in here. You want to keep this one bend at an angle so that it comes down and meets your fiberglass here, and you've got a pretty good area where you could put an oil cooler under here. Now, if you're going to do that, you're going to have to beef up this area. You're going to want to put some strapping down the side here because that oil cooler is going to be heavy and it's going to vibrate, and you're probably going to want to just beef up this entire area. Your other alternative for the oil cooler is in the back here. And you can see here we've already modified this. The oil cooler will go right behind here. We've got the door cut out already, or opening cut out for the oil cooler. And we've done some beefing up. You can see this piece here is a piece of angle which is used to beef up this area. There'll also be a brace that'll go right like that beefs up this area. Down along the side here we've put a doubler plate that's bent. It comes right in here, and that's just beefing up this entire area in here because that oil cooler gets heavy once it gets full of oil and it vibrates. So that's where we're going to put our oil cooler. We've done it with the one in the front, and that works well. We've had a lot of people say putting them in the back works well, so we're going to try that on this airplane. So now we've got all of our sides and our front plates. The only piece left now is this front area right in here. And that's just 2 parts. They come in halves. They look like this. And basically they'll fit in, and they fit pretty basic right in there like this. And the only thing you're going to have to do is put them on, put your cowling back on, reach in through here and mark them and trim them until they get down to where the cowling fits again. And there's nothing really special about these. They're held in place with some little angles that you're made from your aluminum. And it's the pieces that come that you have to cut out yourself. And then there's a brace in the center here that attaches to the engine. Using one of the engine bolts, just take a bolt out, put this piece in, and then when it goes in, there'll be a bolt right here and it'll bolt right there and hook it on. There's also a similar plate like this in the back here, and this plate also is held on by a couple bolts, and they're just the engine bolts themselves here and here, and you take those out and bolt this plate in. Like we said earlier with the oil cooler installation, after our first couple flights we did notice we had higher oil temperature, higher than what we liked. So we went ahead and moved the oil cooler. Now, with talking with other builders, we found several builders who use the oil cooler in the back like we originally did and have had real good success with it. So I guess it's on a case-by-case basis. Anyway, we moved the oil cooler up to the front of the engine on the baffle, and this works real well. Now, one thing you do want to do is mount it with the hose fittings facing forward. That way you can mount the cooler back up against the cylinder and it gives you plenty of room. Do have to get a little creative with your hose fittings. The only downfall with this is that your hose, both hoses now run from here all the way to the back of the engine. And they're about 28 inches long, 24 inches long. Has no effect on the cooling. Once we moved it up here, our oil temperature went down quite a bit, and we were real happy. You just have to run your hoses in there and snake them around and secure them. The one thing you do have to do is make sure that they're not going to rub against something. So you can see, like right here, there's a little piece of rubber, and that's just to protect it from rubbing against the starter right here. You can see this little piece of rubber and the tie is holding it on. So you have to do that all along there. Make sure nothing's going to rub on your hoses. But your oil cooler will work real well up there. At this point, now you want to talk about layout. And what I mean about layout, you're going to need to decide where you're going to put your oil cooler. We're going to put our oil cooler here. The next thing that's going to be coming through here is plug wires. And they'll use a little plastic device like this, and it'll go right here. So you want to think about layout even before you cut this, because you certainly don't want to plan on putting these here and cut that oil door out. So they'll go here, and it's drawn on here. Next thing we're going to look at is cooling tubes, and we've got them marked on here. Here's a cooling tube will go here for our mags. One will go here for our fuel pump. One will go here for the vacuum pump. Another one will go over here for the other mag. You may also want a cooling tube for the gascolator. So you want to start laying them out. Also over here will go the other little plastic shield for the spark plug wires. Okay. You also want to think about cabin heat. Where are you going to get the air for your cabin heat? You can get it off the back of here. A place that a lot of builders have said they've gotten real good success is to actually go lower on the baffle. Go down where the baffle wraps around the cylinders, because if you think about what you're trying to do, you're trying to heat air. This air up in here is ambient temperature, so if it's 20 degrees out, this is basically 20 degrees air. By the time it passes through your heat muff, it's not going to warm up much. If you can pull that air off after it's passed through some fins, it's warmed up by the engine, so you'll get better heat. So we're going to opt to pull some of those off lower than up in here. But these are the kind of things you need to figure out. Don't go drilling these holes. Something may come up and you say, well, I don't want a blast tube here, it's going to interfere with something back here. But start marking them so when you're working back here, you say, oh, well, I'm going to put this here. How's that going to affect my cooling tube? You can see up in here some of those reinforcing that you have to make and put in up in here. And we're looking at the left side of the front baffle. There's one here, and then there's one up in here. Now, something else you're going to have to do is eventually pull this baffle around your cylinders. There's a place right here to drill, and what you're going to want to do is make a little pin that'll cover this baffle. Put safety wire in there and pull it up against the cylinders with safety wire. They give you some plastic tube to run that safety wire through so it doesn't chafe anything. But you're going to want to pull both of these all the way up tight against your cylinders, and that's to direct the air through the cylinders as much as possible. Again, you can see there's quite a bit of room in here if you wanted to put an oil cooler, but you don't want to put this other bend in here. The one downfall in putting the oil cooler up in here is you've got awful long oil lines. They've got to go from here all the way to the back of the engine. Now, a couple alternatives for your cabin heat muffs. One is, like I said, in the directions, you can put it in the back here. And when you put these on, I found that you don't need to cut a full 2-inch hole. Usually a 1-inch hole is give you more than enough air. But this is ambient air behind this. Okay? What we're going to do is come down here lower, like right in this area. This in here should still have pressure because this will pull up against here and form a pressure area. But the air will be coming through here, will be warmed. So you can either put it here, catching some warm air off the cylinders, or down here. You know, you're catching some air after it's passed through some of the fins and heated up. What you want to do is take in consideration the hose too. It's not a very flexible hose, and will it fit there? And yeah, it'll fit there or it'll fit there, and I can direct it around to my heat muff. And the heat muff's right here on the exhaust system. Now we're using a Vetterman exhaust system, Vetterman stainless steel crossover, and the heat muffs we got from Rick Robbins. They're a real nice heat muff. The nice thing about this, as you can see right now, there's no inlets or outlets for the air on this muff. We'll put those on later. You actually put them on yourself. But now it's time to start thinking about what you're going to do. And while we're thinking about the heat muff, you got to remember you've got air in and air out, and you want to think where you're going to put your cabin heat box. We get these boxes from Larry Vetterman. They're a real nice box he gets made up for them. It'll go right here. Now, how we decided to go right there, we've drawn over the entire firewall where we think things may go. We've got a box here for the cabin heat box. We've got a drawing here for our oil pressure sender. We're going to be using all electronic gauges, but they have sending units, and the sending unit will get mounted right there. We've got a box over here for the starter relay. Brake cylinder reservoir. We've even got one for the cabin heat control cable. On the other side, we've got similar things. We've got the heat boxes over there since we're going to have dual heat. Fuel pressure sender. Gascolator. You want to draw on the firewall where these things will go, or where you hope they'll go. And then as you start installing these things, you can see where it's going to interfere or what might interfere, so you can move around. Like I said, a lot of this takes time, and you want to look at it and stand back and think, well, what's this going to do? You also got to think about your control cables, where your control cables are going to come through the firewall. But for right now, we're going to finish up the engine baffle. We've drawn on the firewall, and that gives us time to think about this. But now we can finish our engine baffle. Now, what's left? Well, once this is all riveted together, and it's still got some clecos in, we're not quite done. We haven't cut the hole for the heat muff. We haven't cut the hole for the alternator blast tube. We have cut the hole for the oil cooler because that's where we decided. But the other things we haven't quite decided yet, so we probably won't totally finish this up until we get to that point. With the kit comes a sheet of rubber gasket material. You want to cut it into 3-inch strips, and what you're going to want to do is come down 1 inch and have 2 inches to go around. Now remember, you're trying to seal this area now. This piece goes here in the back, and it'll go on there like this. It'll pop rivet, and you want it so it curls forward. Okay, if it curls back, the air being forced in here can just blow by it. You want it to curl forward, and the purpose for that is that when air comes in here, it builds up pressure and it helps seal against the cowling. So when you're putting it on, if it wants to curl back, turn it around. You want it to curl forward. Now when you come down to the side, you've got two pieces here. Now when you go to put your rubber on, you want to put your rubber on in two pieces. The reason for that is if you ever have to take this off, you can take it off. Also, you don't want to put a rivet where these two pieces of baffle meet. Now, it seems like that's a natural thing to do, but from experience, I'm going to tell you that those rivets will just shear off. This thing wiggles in here. It's amazing how much this engine moves around. So you're going to want to put a rear piece on, okay, and then put a front piece on that will overlap the rear piece. So as the air is coming in, it'll push it against and seal it. And you'll just, put one piece here and maybe another piece that'll come on around the front like this that'll seal when your cowling is on. And you just want to work the whole edge, and really the instructions on this are very good. And once you get the idea of what you're trying to do, you're trying to seal the air in. Once you're done with that, you're going to want to go ahead and take some RTV and seal any small areas with silicone. Up in here is a good example, and just look all around. Now you don't want to put any down along the fins of the engine because you'll just close those fins off. But you just want to look all around the engine wherever there's a hole that you can seal with the high temperature silicone. Go ahead and seal it to prevent any air from leaking out. Before we go any further in the planning stage of the final assembly or even doing anything, we need to look at the instrument panel. Now the instrument panel is in place and it's behind this little board. There's just a board in here. No holes are cut in it, but we need to start planning where we're going to do things. And the reason for this is we start over here. Here's our airspeed and our turning bank and our artificial horizon and our directional gyro will go here. But you got to remember now that this is going to be hooked to a vacuum pump. And there's a bulkhead right here. So we don't want our vacuum pump fittings on this side. We want them on this side. We don't want them on this side of the bulkhead because then we'll have trouble with our hoses. So before you can install your vacuum system, you got to figure out where you're going to need vacuum. Altimeter, VSI, little things. We'll come over here. This is a Rocky Mount instrument engine monitor. It has all our engine instruments on it. Come down here, starter switch. Our switch for our flaps will be here. Starter key here, carb heat. Coming over here, we're going to have our right and left fuel, our radio stacks, and our circuit breakers. And you need to figure out this layout so you know where wiring is going to run. You also want to be figuring up the size of wiring. As far as the control column, you need to start thinking of things. Now, the reason the carb heat is right here, it gives me carb heat, throttle, prop, mixture, and trim tab all in one row. So in an emergency procedure, I can go full throttle and turn the carb heat off at the same time if I needed to. Now with your control column, you want to label all this real nice, but there's a couple things you want to think about. And the one thing is, if your fuel mixture is at the bottom of this control column, you want to make sure you can get your hand in here and not bump the trim. So you want to keep the trim up high enough. You don't want to get these too close that they interfere with each other. You want to be able to get in here under the throttle and be able to work the prop or work the mixture. And we can do that. We've got lots of room in here. But these are just things that you want to be considering. Also, with the control column, figuring out where you're going to go through the firewall to run your cables, your prop and mixture and throttle cables. So these are things you have to really start deciding now. We still haven't cut anything in our instrument panel out. And the reasons for that is I'll sit in here and I'll go, well, I don't like this here, I want it over here, or I don't want this here. A case in point, over on this side of the instrument panel, right here is my heat control. And at first I thought, well, I'll put the heat control out of the way, I'll put it under here, and I'll put my headset jacks right there. But now when I go for my heat control, my headset wire's hanging in the way, and I may get that, so a better way is put the headset jacks here, and now I can get to my heat control without any problems. So little things like that. You want to set this up and look at it and just imagine flying the airplane and think, boy, this would be a lot more usable if this was over here or that was over there. And it's really a personal thing. We set this up because here's all of our instruments, including our VOR and our engine instruments right in here, and I can just scan while I'm flying and just see everything, and I don't have to look over here for things. So this is what you want to do before you go any further, before you even start punching holes in your firewall and getting things lined up. The next thing we want to go ahead and install is our throttle and mixture cables. Now the reason for that is they're very difficult to position, so they can only go in one place. So you want to put them where they need to be. Now you can see here, here's our throttle cable right here. It's coming off our carburetor right there. Now what we did was actually hook both our throttle and our mixture cables up. And we'll get the mixture cable out of the way right now. Here's our throttle cable, and we use Cablecraft cables. We used them on our first airplane and they've served us well, so we put them on our second one. We have to now make a bracket to hold the cables, and Cablecraft comes with a groove right here in their cable where you can attach something to hold it. So what we did, we actually made our own bracket, and it looks like this, and it's made out of chromoly steel, and it's welded at the end. Now how this attaches is this and this have holes in it, and they actually will mount to the rear 2 bolts of the carburetor, where the carburetor hooks to the sump, and that's right up in here, okay, the 2 back bolts. This third attachment point then gets hooked right into the sump of the engine itself, and now you've got a firm attachment. Now on the back of this are the attachment plates that attach the Cablecraft cables to the bracket, and they come with the cable. So this will get mounted, and we'll slide it in here. That'll get mounted just like that. Now this is looking at the back of the engine. Here's our throttle and our mixture cables coming out, and I brought them out through the box that we'd put in the firewall, and that gave me a good area to give a nice gradual bend. They come back around, and we'll zoom in here, and you can see where they're attached to the bracket we made. You can see here's that bracket right here, and here's where the throttle cable is attached to it, and the mixture cable is attached in the back here, right in here. And you can see here's the mixture cable right here, throttle cable in front. Now you'll notice they're at different angles, and that's right, because the controls are at different angles. And we'll try and get you a shot around on the front. And looking from the front, here's our throttle cable, and it's right here, and it moves very easily. Okay, and then right behind it is our mixture cable right here, and I'll have to go on the inside to show you the movement of it. But it just comes right on back, and now I'm turning it back with the knob where I can push the button in and move it all in one time. But they both work very freely and not binding. And that's basically hooking up the throttle and mixture. Now the prop cable for the prop governor comes out on the pilot side, and this is right here. Now it's a much longer cable, and from here it's very difficult to see because it gets lost, but it goes right around and hooks into a bracket that we made just like we made the one for the throttle and mixture. And it gets hooked into a bracket and goes right down into the prop governor and gets hooked in. And you really can't see it. There's not enough room to even look down in there, much less see it. But that's where the cable for the prop governor comes through. Now to start the fuel system, what we do first is mount the electric fuel pump, which goes right here, just under the gear. Now, what you want to be careful is that, remember, you're going to have a fuel line come in, and the fuel line actually comes in somewhere up in here, so we'll just barely clear that. But the fuel pump's mounted, and we'll either run the aluminum tubing from the fuel pump here forward to the firewall, or we may even use a number 6 hose. But for right now, the fuel pump's in. We're not going to run our tubing out to our fuel selector valve right now, because we can still take the control column and bend it out of the way, but once we've wired or plumbed some fuel lines into it, it makes it much more difficult. Then from there we go around to the forward part of the firewall. Then on the forward part of the firewall, the first thing we need to mount is the gascolator. Now, the gascolator we use came off of a 152 or 172, about the same. We had to make the gascolator bracket mount. The reason I like this is it has the pull stem that you can pull to drain the gascolator, and it drains out of the bottom. Also has the attachment at the top for our primer system. Now we're using the Rocky Mountain engine monitor, which uses an electronic fuel flow sensor, and this is the fuel flow sensor here, and they recommend having this forward of the gascolator, since the gascolator acts as a filter. So this is what we've come up with. The gascolator will go right here on the firewall, right there, and the fuel lines will then be plumbed from here out and over to the mechanical fuel pump. Then from the top of here, it'll go up into our priming system, and then of course we have our drain down on the bottom here, which will come out, and that'll be our gascolator drain. So that's the next thing we need to do, is go ahead and mount this. Next thing we need to know how to do is how to make up our fuel hoses. Now we use the standard Strataflex hose. This is a number 6, and the standard aircraft fittings. It's not a real hard job. The one thing you will need to do is get yourself a set, or make yourself a set of mandrels. Now in Sport Aviation, a year or so ago, they had a article on how to make these mandrels. But you need a set of mandrels. What the mandrel's for, if you look inside this fitting, your fitting comes apart. And this is the stem that'll fit down inside of the hose right here. Okay? And there's a very sharp edge on this stem right here. And as it's going down inside the hose, it can shave off some of the hose and actually create a blockage. So you screw your mandrel into it, and that helps prevent that edge from shaving off a little bit of the hose. It also helps to guide the fitting now into the hose. So what you need to do to put your first fitting on is you go ahead and put your outer collar on, and it screws on counterclockwise. And what you need to do is go ahead and screw this on until it bottoms out, and it's actually threading right down onto the hose. Once it bottoms out, back it off a quarter of a turn. Okay. Then take your mandrel and the rest of your hose connector, and go ahead and tighten your mandrel down onto the connector good and tight. The next thing you want to do is oil it. And without oil on this thing, it'll never go together. I can guarantee you that. Want a little oil right down in the hose, and some on your mandrel and your fitting. Then you want to push this in. Now, a good practice to get into before you push this in is take a piece of masking tape. We take the masking tape and wrap it around the hose. Now, the reason for the masking tape is if in the process of screwing the connector in, it pushes the hose out, we'll know it. Next thing you want to do is go ahead and push this mandrel and connector down into the hose until it starts to thread. Once it starts to thread, you can go ahead and clamp it into a vise, and then finish screwing it in using your mandrel. Now, if you notice that you're turning but you're not going in, your mandrel and your connector have come loose and you need to tighten them back up again. So you want to screw it back in until you're about 30/2 of an inch from the caps and the collar getting together. And they'll start getting reasonably tight here in a second. Actually, they'll start getting unreasonably tight after a while. Alright. Then once you've got that, you can go ahead and take your mandrel out. And there's your connector on your hose. And we can look and see the tape is not separated from the collar, so we know in the process that the hose wasn't pushed out. And you want to get this tight enough so you can turn this freely, but you don't want a whole lot of space in there. Now, the other type of connector that you may use is your 45 or 90-degree connector. They also come with the outer collar, just like the straight one that would get screwed on, but they don't have a two-piece, and you can't use a mandrel on it. It comes with one piece, like this. This is a 45, and you can see there's no way to get a mandrel in it. And you just shove that down inside with some oil and put a wrench on this collar here and start turning it in. And that's all there is to putting those together. Now, once these are together, an extremely good practice is to go ahead then and blow air through these things. If you've got a hose with two straight connectors, one on each end, what we like to do is blow them out, pull the hose straight, and look down through them and see if there's anything in there. So you want to make sure your hose is good and clean. With the 40 or the 45 or the 90-degree fittings on it, you're not able to do that. But that's how you make your hoses up. We start plumbing our fuel system by running a hose from the electric fuel pump up to the forward side of the gascolator, and that's on the inside, on the pilot side. We then come up and put an elbow, and the first thing we hit, because we're using a Rocky Mountain engine monitor, it has a fuel flow sensor. And so we put our fuel flow sensor in here. They recommend doing that so it's behind the gascolator, which acts as a filter. Coming off the fuel flow sensor, we put our first hose, which is this one right here, and this hose will just go along the back of the engine all the way to the other side of the manual fuel pump, which is on the co-pilot side. Now, the fittings that go in your fuel pumps are special fittings. It's not a pipe thread, but a standard straight thread. So you have to get a special fitting, and you can get these fittings from VANS, and they come in straight, 90-degree elbow, or they even come where you can T it. And we've got the T fitting. And this line here that comes straight out is the T fitting. And that's a number 4 hose that comes all the way up to the firewall where our fuel pressure sender is. Again, it's electronic sender, so it's right here, and we've had to just get some fittings so we can feed it into the fuel pressure sender. On the other side of that fitting, again, is a number 6. Now, when you're putting fuel systems together, remember you have to be able to supply 120 to 150 times the amount of fuel the engines needs to run. And a number 6 fuel line will do that quite adequately. So we come off the other fitting, come down, and this fitting will then wind around and goes over to the carburetor. Now we've put our heat muff on temporarily just so we can see where it's going to be for when this hose comes around to the carburetor. So we've put that on. Now back on the fuel pump, you'll notice there's a number 3 fitting. And that number 3 fitting comes down and it'll wander around and actually dumps overboard back here. And what that fitting is an emergency drain. And if your diaphragm in your pump starts to spring a leak, you'll start getting fuel out of there. If you don't get fuel out of there, everything's fine. Next, we worked on the priming system. Now, the primer comes out of the top of the gascolator. Now, we use an electric prime, and all that means is we use an electric solenoid which opens this line up. We have to turn our electric boost pump on, which will pressurize the gascolator, and then it comes up this line, and this is just a number 2 fitting and a number 2 line, and it comes up here to this little solenoid right here. And from the solenoid it comes out, and right behind the engine mount there's a T that looks just like this. It's just a number 2 T. One side of the T comes up here, the other side then comes along the engine mount down here where I've put some loops. Now, all the loops are for is just some vibration, because remember, the engine's going to move and the engine mount won't. So we've got some loops. We come over here and we attach it. Let me get the spark plug line so you can see how we attach it here. We just take a screw out of the valve cover gasket, or valve cover itself, and we put a washer behind it, and then we put a fitting to hold it. We then come along here to another T. The top of the T then goes into the number 4 cylinder, and what we put into the cylinders, we take the plugs out right here, and we put an AN 816 2D in there. And then off the other side of the T comes to another fitting where we attach it into cylinder 2. Now, out of the top of the T that comes off of the fitting, we run another line which goes along the back side of the engine, and that goes all the way around to the number 1 cylinder, and we do the same thing there. We don't put a primer nozzle into the number 3 because that's where we'll pull our manifold pressure off of. Then off of the bottom of the gascolator, the last thing we want, and there's the reason we use these gascolators off of Cessna 152s or 172s, is a drain, and the drain comes right here, and there's a little cable right here and a little fitting that when you pull the cable, it'll lift that fitting up, and that drains your gascolator. So that's the fuel system. It's not very difficult, and it's really just start at the beginning and work your way right on through. The orange that you see is fire sleeve, and we fire sleeved everything. The fire sleeve, one protects the fuel lines from a fire, as it's called. The other, it helps to keep the fuel lines cool. Now, we'll run an air tube down to the fuel pump later on to help cool it also. And some people even go ahead and put a shroud over the gascolator, if that's a problem, to help keep the gascolator cool. But that's the fuel system. The next thing we had to do from here was go to the oil system. Now, before you run your oil lines, you have to first identify where you're going to run your oil lines from. Now, this is a new engine from VANS, and what you're going to see here is this fitting right here is the big fitting. And if I can get it off here, you can see what it looks like. I can't get it off easy. But that's your sump breather line. Then with the new engines, right here is a fitting that's already on, and that's your pressure line. That's your line that feeds the oil to your oil cooler. And like I said, that one's already on and safety wired in. Right next to it, there was a plug, and I took the plug out and put an AN 816 66D. And what the 66D does is take it from a number 8 oil fitting or line to a number 6. We're going to use number 6 fittings here. So that's where our oil lines are going to come from, is here and here. This is your feed, this is your pressure area, this is your no pressure, this is your return. This is the oil cooler that we're going to use, and it's a regular aircraft oil cooler. Again, we had to put the right fittings and use the AN 816 fittings. A couple things. On the oil cooler, you're going to mount it with bolts, and you don't want to just put a bolt on one of these flanges. That flange won't take the vibration. You need to put a bolt through like we've done here on both flanges, and you need to take a piece of chromoly or stainless and make a sleeve for your bolt so that when the bolt compresses, it's going to bottom out on this sleeve so it's holding by both flanges. An aluminum tube won't work because it'll constantly compress, it's too soft. One of the things that we've also done is put an oil flap door on ours. In normal working, the door will be open, but in the winter when it's cold we'll pull a line that'll close it off. We didn't close all of it off just in case this jammed, it wouldn't totally block the oil cooler. Our oil cooler, we had to make a little ring to go around it, and this was to hold it off away from the baffle a little bit so we got some more air in there. Now we go ahead and we mount our oil cooler on the back of the baffle. And you can see the hole right here, and it'll mount right in here like this, and our oil door will go just like that. And then we need to go ahead and run our hoses over to our engine. Like the fuel lines, the oil lines, we just run them in the way that the flow goes. We came out of our pressure fitting, and we used a 45-degree fitting there. And we came up around the engine mount. You can see we can get our hand under there, so we've got plenty of clearance on the engine mount, to another 45-degree fitting to the top of our oil cooler. And the oil goes from the top of the cooler down. Then at the bottom of the cooler, and it's a little difficult to see, but down at the bottom of the cooler we brought another hose. We actually put a 90-degree fitting there and brought this hose up and around and down to our other fitting for our return. And that's got our oil cooler all plumbed in. And the oil cooler, you can see, has got the little door here that opens and closes. The only other part of the oil system is the oil temperature. Of course, that's electronic, and that's in here. And then we've got our oil pressure. Now, our oil pressure we'll take from the other side of the engine, and we'll show you where we pulled that out. On the back of the engine, right between the vacuum pump and the engine mount, was a plug. And we took that plug out and we put an AN816 4D fitting in there, and that's where our oil pressure line will come out of. Okay, here's that hose right here that came out of the engine, and it's going right down to this, which is our oil pressure sender. And like I said, we're using all electronic stuff, so we mounted this sender on the firewall. Now we'll also use this line to pressurize our oil system. And what I mean by that, we won't put 5 quarts of oil in the dipstick. We'll actually pump 5 quarts of oil or 7 quarts of oil through this line into the engine to prime the oil pump and to prime the bearings and all. And we'll show you how we did that in a little bit. Now, we talked about the manifold pressure, and here's where we hook our manifold pressure. Our other primer lines right here goes into our number 1 cylinder, and it comes down along, and here's another curly Q just to keep some vibration in there. And then where we could put a primer line, we've put our manifold pressure line, and again it comes over and right to the firewall where our manifold pressure sender is. Next, we started working on our cabin heat. Now, cabin heat's important, especially in the colder weather, so you want to take some care in doing this right. You also got to watch out that your lines for your cabin heat doesn't interfere with things. That's why we put the heat muffs in place when we were working on other things. Our cabin heat box mounts on the firewall, and we get these from Larry Vetterman, same person we got our exhaust pipes from. And essentially when this is down, the air coming in here goes in and through the firewall, and when this is up, then it just comes in this and on out and bypasses it. The heat muff is mounted on the exhaust pipe, and we get these from Rick Robbins. The nice thing about Rick's is the inlets and outlets aren't mounted when you get them. It's a tube, and you mount it on your exhaust pipe, and then you can move your inlets and outlets where you want them, and then you actually just drill and pop rivet them in place, and then cut a hole in the heat muff itself. Now when you go to cut that hole, you don't need to cut a big 2-inch hole. The same thing up where we get our air up here on the engine, it was on this slant right here, we mounted our heat muff inlet there. You don't need to cut a big 2-inch hole there. I think we cut a 1-inch hole, and we found you cut a 2-inch hole, you get so much air it can't cool or can't heat it. All you get is cold air, and it really takes a lot of cooling away from your rear cylinders. So we've mounted that, and we've got these in place. Next, you want to go ahead and cut your hoses. Now, the hoses you can get from VANS aircraft, and they just slide on like this. And what you want to do is then put a hose clamp on there. On the inside of this is some wire wrapped around in there, and a lot of people, it's a good idea to pull some of that wire and then bend it up and clamp that wire with your hose clamp so it doesn't continue to unravel. From there, it goes down to your heat muff. Then it comes out of your engine, and these are all cut and marked already. It'll come out of your engine up here. And comes down around and into your heat muff. So that's essentially how it'll wire plumb up. Cool air comes down off your engine. Now the reason we mounted it back in here was to get some warming as the air passes over the cylinders. Instead of up in here, you can put it up in here or put it on the back side, but then you're just getting cold air. So we try to get some warming. So we're coming out of here, comes down into our heat muff and back up. Now another trick is Rick tells you in his instructions to drill 4 or 5 holes to allow air into the muff. And a good guideline is if you drill 5 holes for air going in, only drill 4 holes for air coming out. That'll build pressure up in here and allow the air to heat. If you've got 5 holes coming in and 5 holes coming out, the air just passes through so fast it doesn't heat. So you want to build up a little pressure. At the same time, you don't want to restrict air so much that it doesn't flow, because remember, this is cooling this heat muff too. So you do want to get a little bit of back pressure in there. I'll show you what Rick's heat muff looks like. Now we've taken it off. What we did was we clamped our inlets and outlet flanges onto the heat muff, and we drew a line and marked where they went and put a couple index holes. We then drilled our holes. Now this is the outlet side. You can see where the holes were drilled, and our flange will then go like this over it. The inlet side has already been drilled and pop riveted on, and like I said, the inlet side has 6 holes. The outlet side only has 5 holes. That's so the air coming in will build up some pressure inside here and will allow the air to heat a little bit. The next thing we're going to work on is the vacuum system. Now the vacuum system is what drives your gyros, your directional gyro and your artificial horizon. Vacuum system really has 3 components. One, it has your vacuum regulator. Now this vacuum regulator came out of a 172 Cessna. Picked it up at a junkyard. It's basically just has the regulator. It does have a removable filter that you need to remove and replace when it's dirty. And then it just has a big nut and some washers, and it's going to be used for mounting. Then on the bottom is the actual adjustment for the regulator. The second part is your vacuum filter. Now remember, this is a vacuum system, so the air is sucked through the filter, through your instruments, through the vacuum pump, and on overboard. So your filter, again, this came out of a 172. It's just an airborne filter. Has 2 outlets, which is nice, 1 for each instrument. And the filter, you just have to check periodically and replace when it's dirty. The third component of your vacuum system is your vacuum pump. Your vacuum pump mounts on the back of the engine casing, and it has 4 bolts. And you'll find that 3 of the bolts are easy to get to, and there's 1 bolt down here on the bottom. It's very difficult, but little patience, you can get to it. Now you have 2 connections, an in and an out, and they're easy to tell which is which because it's actually marked right on the pump, in and out. Now remember, this is air coming in, so this is the side that goes to your vacuum regulator because the air's flowing this way, sucking through the regulator. This is out, this is air coming out of the vacuum pump, and it'll just go down and pump overboard. It's really not needed. So this is your vacuum pump, and once you've got this mounted and your regulator mounted, you're ready to plumb these two together. Once we've mounted the regulator on the firewall, and remember you want to mount the regulator in front of where your gyros are going to be, so you've got the most direct shot for your hoses. Then you want to mount your hose from your vacuum pump to your regulator. And these aren't just like a heater hose, this is a special vacuum hose. It's an extra thick wall, because if you don't use the right hose, you'll actually suck this hose closed and it won't do you any good at all. So our hoses are put in, they're connected with hose clamps. This is our outlet hose, and it's not connected to anything. It's just a loose end, and it'll be secured later. And it just goes on down here, and the air gets drawn through here, through the pump, on out and overboard. And that's the vacuum system. A few more things that we need to do on the forward end of the firewall before we go and back is one, cooling tubes. Now you can see the cooling tubes, we've got them mounted here. There's 4 of them here. This one goes to a mag, this one goes to a vacuum pump, this one goes to a fuel pump, this one goes to the other mag. And these are just to supply cool, fresh air to those units to help cool them. We'll bring you around the side here and show you what they look like. On the back side you can see the tubes coming out of the baffle. Here's the one going down to the vacuum pump, and this one going down to the mag. This one goes all the way down to the fuel pump. And these are just to help cool the devices while it's in flight and in operation. The second thing we want to make sure we've installed, and we're going to need it for the next step, is our little reservoir for our brake system. Now, you can't see much of it, it's sort of behind the engine mount here, but the reservoir's here, it goes through the firewall, and we've actually put plate nuts to bolt this onto the firewall. And this will just get plumbed into the brake system on the forward side. And it has a little cap here that allows air to go through it. And you don't want to fill the reservoir up, because we're going to back pressure the brake system, pumping fluid from the wheels up to the reservoir. But you need to go ahead and mount that now. In bleeding out your brake system, there's 2 schools of thought. Some people like to fill the reservoir up and then try and draw the fluid down to the brakes. The problem with that is when you look at your brake system, your brake lines from your reservoir are all attached to the top of everything. So you're going to be sucking fluid from the top, trapping air in there. One thing we've tried is actually pumping fluid from the bottom up, and we found this to work real well, because all your brake lines attach into the bottom of your brake cylinders and everything, so you're forcing fluid up and forcing the air up and out as you're doing it. To do this, first you get to your brake cylinder, and there's a little black cover, and you want to take that off and you want to save that. And it's just a little black rubber cap. Next, there's actually 2 nuts here, and it's the smallest one, and you want to loosen that up. Make sure it's loose, just a little wrench. To do this, what we've done is taken a regular oil can, and we got a brand new one and clean, a couple little pieces of rubber hose, and an actual piece of the brake line, the nylon brake line that you used. I used regular aircraft hydraulic brake fluid, filled this up, and the first thing you want to do is pump this air out. So we'll pump until we're not getting any air. Then you simply attach that right to this. You open your petcock up, and then from here you just start pumping brake fluid. Okay, so what you're doing is filling this up, and then you're going to start filling all your brake lines up. And from the inside you can actually see the fluid coming in. The fluid will come in on the left side and slowly migrate over to the right side, and it'll fill the right hand cylinder up, And then from there it'll go right on up into the reservoir.
Alright, so brake cylinder, reservoir, whichever.
And that's all there is to pumping your brake fluid into your brake system. Once you get it up into the reservoir, you simply tighten your little valve, put your black dust cover back on, which will keep dirt out of that, and you're all done. You'll probably want to go around and put a little additional fluid in your reservoir. You want to keep it, pretty full. But basically that's an easy way to backfill your brake system. Eventually we get down to the fun part, the instrument panel. Now the instrument panel you should have been working on long ago, trying to figure out what you wanted, figuring out what radios you want to get, what kind of instrumentation you want to get. Rough layouts of the instrument panel, but sooner or later you're going to have to come down to some real hardcore decisions. Now our instrument panel here we've laid out, and we have our instruments, our airspeed, artificial horizon, altimeter, and we've laid this out for scanning so we can scan around. We use an electric primer system, so our primer switch is up here, vacuum gauge is here, and you can see all of our gauges that we'd watch in flight are right here. Our flight gauges, vacuum gauge. This is our head off of our nav. This is a Rocky Mountain instrument engine monitor, which has all of our engine instruments in one little package, and we'll talk more about that. But this is what we'd watch in flight. Now we've got our flap switch here, our starter switch here, and our carb heat. Now our carb heat is dead center of our instrument panel, so it would be carb heat, and then our throttle and everything is below that. So all our controls, our engine controls, are in line. Cylinder select switch for the engine monitor, so we can look at all 4 cylinders. Then we come over to our radio stack, and we've got our radio stack here with our GPS and dual comms and nav and transponder. Fuel gauges went up here only because we were out of room where to put them. They're not a gauge that you watch a lot. Then further over here is our circuit breakers. Next to our circuit breakers is a low voltage light. Now some things you may want to look at is on the ends here we have our heat for our cabin is right here. And this is something you want to look at. It's got to be comfortable. It's got to be where you can get to it. The next thing you got to remember is there are some things that get in your way. One, there's the braces for your instrument panel, which is one here, one in the center, and one over here. So you want to draw them on your panel so you don't put a radio that's going to impact, or an instrument that's going to impact there. Likewise with your radio stack, some radio stacks are going to go all the way through, back through the sub panel, so you want to make sure that's not going to interfere with these. So once you've got this laid out, then you have to decide how you're going to cut your instrument panel. Now most of these are round holes, 3 1/4 inch holes. These are 2 1/16 inch holes, and these can be cut with a circle cutter. What you want to do is cut first, and then on a test piece, cut a hole, try it on your instrument, cut a hole, try it on your instrument. You have to remember there's mounting screws, and there's 2 ways to find the holes for your mounting screws. From Aircraft Spruce, they make a little instrument gauge like this, and basically what you do is you set it down and you mark the center of where your instrument would go, and then your 4 corner holes are there, and you can center punch those. And what you want to do is draw a line on your instrument panel and figure up your spacing and whatnot. This also has your spacing, and it tells you to use this outer hole as your space, and it gives you about a 1/2 inch space between your instruments. Another way to do is a thing you can get from Avery Enterprises, and that's this. And basically what you do is you cut your hole to the size you want, and this has a raised area, and this would fit down in the hole, and then you mark your corners. So the nice thing about this, if your hole's off a little bit with this, your center hole's off a little bit, your corners aren't going to match up. Or with this one, you're actually going to cut your circular hole, and then you're going to match your corners up. This is how we did ours. This worked real well. The next thing you have to worry about is the square holes for your instrument panel, or your radio stack on your instrument panel. A quick way, and probably one of the nicer ways, is to draw on here the exact size you need and take it to a machine shop. They can mill this out in a matter of 15-20 minutes. Gives you a nice square hole, and you don't have to go through a whole lot of filing and cleaning up and whatnot, and they can cut it out for you real nice. Laying out your instruments, especially down in here, you have to remember you got to give yourself enough room between instruments to keep this instrument panel sturdy. Don't get your instruments too close together. On your radio stack and like the Rocky Mountain engine monitor, the big hole that you cut out here, you want to put a piece of reinforcing, and we'll show you on our instrument panel here in a second, to stiffen this up. It also gives you a place to mount the instruments and whatnot. Now there's two ways that you can mount these instruments here. Remember, two of these are gyros, your artificial horizon and your directional gyro, and your turn and bank with is basically an electrical gyro. You can cut your instrument panel and mount them right to that, and that works real well. Or what we like to do is actually cut a little sub panel that goes over top of this and is shock mounted, and our instruments will be mounted to that. Okay, talking about that little sub panel, here's how our sub panel came out. Now, if you're not going to use a sub panel, this is what your instrument panel would look like. Basically, your holes cut out and your four corner holes. And like for the airspeed indicator, would just fit right in there and would attach with screws. Okay, now how we got those holes, like I said, with the little Avery jig, is you cut your hole, you set that right in there, like that, and you mark your four corner holes. Now, a couple things you may want to do. One is on your artificial horizon, you want to elongate your holes a little bit in each direction, because you'll find you'll have to turn your artificial horizon to get it level. All planes don't fly at the same level attitude. So by elongating these holes a little bit, gives you a little bit of turn to turn, and you can tune your artificial horizon. Now, like I said, this is a sub panel, and it fits over top the main instrument panel, and it'll fit right here like this, and it'll be held in place with some little shock mounted units, little rubber shocks. The back side, if you're going to do this, you have to cut much bigger holes because the instruments are much bigger on the back side than they are on the front. But this is how our instrument panel came out. All of our flight instruments are here. Right here will go the control for our ELT. We'll plug right in there. Over here will be the control for the flap door on the oil cooler, heat. Down here, these two holes are where our headphone jacks will plug into. Vacuum gauge, our head for our nav, and just like we showed you on the layout board. Now, we had these cut. A friend of mine has a very nice milling machine, and I just drew on here the size I wanted, went over there and we cut these out with his milling machine. But you could do the same thing to a machine shop. Now remember, we were saying you have to mount, you get cases that have to mount in here. I'm going to turn this around. So where the radio stacks were, we took some 062 angle and put on here. One, this gives us a place to mount the radio stacks on, and two, it helps to stiffen this back up. We cut a lot of aluminum out of here. Same thing on the Rocky Mountain engine monitor. Okay, a lot of things like our circuit breakers, we have little sub panels, and they get plate nuts to help hold them in. And so you just, it takes a little time, a little figuring. You can lay it all out. Just mark where there's going to be things that's going to interfere with your layout so you don't try and put things there. One thing we didn't do, we didn't paint this surface. We purposely masking taped this off so when we mount our radio stacks, they'll get grounded to the rest of the instrument panel well. And we didn't paint the back at all, just so when things went on, they got grounded well to the instrument panel. Now there's lots of things you can do to the instrument panel. A friend of mine put wood veneer all over his. It was absolutely gorgeous. Painting it to the same color as the interior works well, and that's really up to you how you're going to do your interior. But this is basically what it'll lay out. Now, things to remember, we're using the Terra radios, which are very long, and they'll go through here and on through the sub panel. Other things you have to think about is right here, these are gyros, and they're air-driven gyros off your vacuum pump, and there's hoses that are going to come through from your vacuum pump. So on your sub panel, you're going to have to cut some holes, and we'll go around to the airplane here in a second. We'll show you on the sub panel. But once you get this cut out, then you can start doing your sub panel. Now, something we like to do is mark our instrument panel. And on here you can see this will be our airspeed indicator right here, and underneath I've marked it. Maximum flaps 100 miles an hour, maximum cruise 180, never exceed 210. And they line up with the colors that are on the airspeed indicator. And how I did these were rub-offs that you can get from a stationery store. And you take a little tape and put tape on here in a nice straight line, and then you just rub these rub-offs on. And then once they're on, you can take some clear shellac or varnish and go over them so they don't come off. And you can do a lot of stenciling on your instrument panel with that. We'll mark things like up in here is where there's a little switch here for our primer, and it'll get marked primer under here. So that's how one way you can mark your instrument panel, and it looks a little bit nicer than the little plastic strips, labeling strips. So let's take you around, we'll show you what the sub panel looks like to receive this. This is looking at our sub panel. Now, we got to make arrangements for some things. One, the radio stack, and you can see I've cut the hole where my radios will come through my instrument panel into my sub panel. Cut the hole a little small, and then took my seaming pliers and bent a little lip here, and that reinforced it. You can also cut this out and then just go ahead and use pieces of angle and rivet on here to help stiffen this back up also. We've got things like rubber grommet. This is where the wiring, the electrical wiring coming from the alternator and all, will come through here. This grommet here is where all the sensor leads coming to our Rocky Mountain engine monitor come, and the engine monitor sits right here. That's why this grommet's here. These grommets here are for the vacuum line hoses that'll come just on the other side. I'm looking right through this hole here. I can see my regulator. So there'll be a hose in here and here where my vacuum comes into my instruments. These holes are where the line goes back out, and my filter will be mounted up under here. There's little snap plugs here. That's where my control cables go through. One will be for my oil flap door, one will be for my cabin heat. I've also run the line in for my static system, which goes all the way into the back, and that's already comes up, and that'll come right over to my instruments here, and it gets daisy chained through all my instruments. There's another snap plug right here, and that's where my pitot tube line, which is the same type of plastic line, will come up and right to my airspeed indicators. That's right here. So you really need to put your instrument panel on and see what you need to bring through and line it all up. Before we put the instrument panel in and start wiring everything in, there's a couple things we want to do. One, we want to get our controls hooked up into our little sub panel here, make sure that's what we want. And this will get put up here a little bit neater like that. The second thing is the firewall. We need to put some foam padding on the firewall for two things. One, for noise, and the other is for heat. And you can see down in here how it's all nice and shiny. That's aluminum foil, actually, that has been glued onto a black firewall foam, and we'll show you how we did that in a second. But basically, you just cut pieces of this foam to fit in between all the little angles of the firewall, and then glue it in. You've glued the aluminum foil on it first. Then once it's all in, this is just plain old duct tape, which closes all the seams up and makes it nice. And this will keep a lot of the engine heat from coming back into you in the summer, and it makes it a lot quieter in the airplane. Without that, it's really noisy in here. The second thing you need to start thinking about is electrical runs. And we covered that in the fuselage tape, where we run the electrical wires down one side and antennas down the other side, just to keep it away from each other. So you need to be thinking about that, and you need to be thinking about your interior. But there's, before I put on the instrument panel, I'm going to go ahead and put my filter up under here, because it's a lot easier. I don't have the panel here in the way. I can move this out of the way, and I've got a piece of 6-inch foam rubber down in here. I can lay down in here and work under here very easily. So, but we're getting close to having to put the instrument panel in. One more thing about the instrument panel is lighting your instrument panel, and we'll get into this more as we get the instrument panel mounted. But we use these little cockpit lights, and they're just a little black light, just like that. And we'll actually make a bracket that'll mount on our overhang, and the light will sit right up in here, like this. And these lights are adjustable. They're a little eyeball light, and you can adjust them where you shine them. And we'll put a couple of them to shine down across our instruments. Of course, our radios are all lit, our engine monitor's lit, and we'll put one or two over top of our circuit breakers. So don't worry about lights. We'll get to the lights later, but that's what we use. Now, for the soundproofing, we buy this black foam, and it comes in a big sheet, and you get it from Aircraft Spruce, and it comes in different thicknesses. And I believe the thickness we got looks like either a 1/2 inch or 5/8. And it cuts very easy. You can just cut it with a pair of scissors. And it has a very smooth side and a very rough side. So the smooth side is what we put the aluminum foil on. This is what they call for, believe it or not. Just take a little spray foam or spray adhesive, and you spray on your foam. Little aluminum foil. I like to put the shinier side out. And you give the adhesive just a second or two to dry, and then you just put your aluminum foil right on there. Now, like I said, what you want to do on your instrument panel, you've got all those angles, and you'll cut a piece to go into each angle reasonably tight, and then your duct tape will cover up the seams. It doesn't take long, and that's stuck on there pretty good. And then you just take your scissors and trim it off. And there's your piece. Now, I know a lot of you thinking, why do you need the aluminum foil? Well, a couple things. One, in the winter, it's going to reflect the heat back into the cockpit. In the summer, the back side of the aluminum foil is going to reflect the heat back into the engine compartment to keep you cool. And it looks nice. Once you've done that, what you do is you turn it over, spray another coat of adhesive on the rough side, and that's what gets stuck right to your firewall. And that'll just stick right onto your firewall. Then when you get all your pieces in, now remember, you do this after you've mounted everything to your firewall. All your plate nuts are put on, and you're not going to be drilling holes in your firewall anymore. Then you just duct tape all your seams to match them up. Now, another thing we found to do with this is back in the back part of the fuselage, it's very helpful to put some of this, and we'll show you what we mean. Something we found on our first airplane was by putting several strips of this black foam, 2-3 inches wide and a foot long, back in the back part behind the baggage compartment. You can see the strips here and here. Takes the trash can ringing sound out of the back of this tail cone. So in flight you don't get a lot of noise from back here. And it makes a big difference. You'd be surprised. It takes all the echo out. So we don't worry with the aluminum foil on here, but we just stick these on, one in each compartment between like stringers and up in here. And it really helps to quiet the airplane down in flight. If I haven't given you enough things to think about, I'm going to give you a couple more. While you're working on your instrument panel and working on your wiring runs, the one thing you have to think about is your antennas. Where do you put your antennas? What kind of antennas do you need and what do they look like? Well, we'll show you a couple. And we'll tell you the best place to put these, or at least where I'm told. Now, everything you got to remember, I'm not an electrical engineer, and everything I'm going to tell you about antennas is what other people have told me and what I've read in books. And so don't ask me why. This is because. First of all, this is your transponder antenna. It's a little antenna that'll get mounted on the bottom of the airplane. And why on the bottom of the airplane? Because that's what it's sending signals to, is on the ground. It's a very high frequency antenna, your transponder with your encoder. So you want to keep your antenna lead down to no more than 9 feet. So this can go anywhere on the bottom of the airplane, preferably as short a lead as possible. It shouldn't have any interference with your Navcom antennas or anything else. And it simply is a screw on it, has a nut. And the one from Terra comes with a little backing plate, so this goes up through your fuselage, your backing plate goes on, and then your nut tightens it down. So that's your transponder antenna. And your encoder, your Mode C encoder, of course, runs through your transponder, so they all use the same antenna. For those of you that are putting GPS in, you have GPS antennas. This is the one from ours. Again, is Terra. Now, something we did was make little backing plates. Now, this one's screwed on right now, but this is the backing plate for my other antenna. And you can see all the backing plate is a piece of 062 aluminum with some plate nuts. So you don't put plate nuts into the belly. This will go, the backing plate goes on the inside, the antenna goes on the outside, and then your screws go through your antenna into your backing plate. Now, your GPS antenna has to be on the top, pointing up. I'm told some people have put them in their wingtips. Then that's fine as long as it's pointing up. Most people put them on the back of the fuselage. Now, the GPS antenna doesn't have a front and back, but it does have a side to side. Okay, and your particular antenna will tell you that it has to mount in a certain way so it picks up your antenna right, or your signals right. So that's what a GPS antenna looks like, and that'll come with its own leads. It's a very small coax lead. Next comes your ELT antenna. Your ELT antenna will look like that. We made our backing plate for that antenna, and basically we just took a circle cutter and cut a piece of aluminum out. So we'll cut a hole in the top of the airplane, stick this in, put our reinforcing plate on. Some people mount their ELT antennas inside the airplane. I'm told if you want your ELT to work right, it's best on the outside, and probably like dead center of the fuselage, back far enough so your canopy doesn't hit it. But that's up to you where you want to put it. Look at your particular radio books. They'll give you suggestions where to put your antennas to get the best usage of them. One of the more difficult is your comm antennas. Now, this is a 45-degree antenna, and it could go on the top. Actually, it's meant to go on the bottom of the airplane like this. And again, here's the doubler plate. The doubler plate will go inside, sandwiching the doubler plate and the antenna onto the skin. Now, you want to put your antennas on before you paint, because you want bare aluminum for your antenna to sit on to get your ground plane. Okay, so it'll go just like that. Now, ground plane. Don't ask me to explain ground plane, but I'll explain how ground plane works. The instructions that came with these antennas say that you need a 42-inch ground plane. Now, what that means in real life is wherever your antenna is, you need a 21-inch circumference, 42 inches across, 21 inches out, all the way around, of aluminum to get your proper ground plane. Now, this is on an aluminum airplane. So you've got 21 inches from here to here. The next thing, if you're going to put two, now you can run the same comm off of one antenna, but you lose a lot of signal. So if you're going to have two radios, it's best to have two antennas. And I'm also told that if you put this too close, like if this is the edge of the airplane here, stations out in this direction won't get as good a signal as stations out in this direction. You lose some of your signal strength. Now, your next antenna, where do you put your next antenna? Your next antenna has to be at least 21 inches away from your other antenna. It has to have its own 42-inch ground plane, and there can't be another antenna within that 42-inch ground plane. So this makes it a little more difficult. Where do we put it on ours? Well, we put our first comm antenna basically under the seats of the fuselage. The next comm antenna, and we'll show you the placement, was directly behind it, and we got to it through the little 4-inch access panel back in the baggage compartment. So you need your antennas 21 inches apart and at least 21 inches from all the surfaces, so you get a good ground plane. The last antenna that we put on was our nav antenna. Now this is what a lot of people refer to as a whisker antenna, and it just comes with a little nylon block and your stainless steel whiskers. And this actually came off of a 172 or 152 Cessna. You can pick them up at the junkyard, and they work really well. The nice thing about this particular antenna is it can work both as your VOR antenna and a glide slope antenna. You can get both out of the one antenna. There are some very nice little wingtip antennas. We make them for some people that work real well for just VOR. It's a tuned antenna that you can put in your wingtip, but it's tuned to just the VOR frequencies. It won't work for glide slope. These little whisker antennas work for both. Now, they're designed to work with the whiskers pointing back. A lot of people will put them with the whiskers pointing forward, especially on the tail draggers, because of eye clearance. Some people mount them on the belly on tail draggers because of eye clearance. But all the radio guys I talk to say, yeah, they'll work all right, but for good performance, mount them on the top of the vertical stabilizer. That's where they work the best. So those are your antennas, and those are some things to think about. Like I said, you got to think about your 42-inch ground plane, keeping your antennas 21 inches apart. Now, your transponder antenna does not work into that 21 inches. You can have your transponder closer to your comm because it's totally different frequency range and shouldn't interfere with your comm. And I say shouldn't, so you know, everybody I talk to say it shouldn't interfere with it. Your GPS has to point up. If you're going to put a marker beacon antenna, remember it has to point down, because it's picking up marker beacon stations on the ground. And marker beacon antenna can be mounted also in the wingtip as long as it's pointing down. So once you decide where you're going to place your antennas, then you can start working on your wiring for your antennas. Starting underneath the airplane, our first comm antenna, like we said, is basically under the seat area, and it's right here on the bottom. Our next comm antenna is back quite a ways, and you can see it back there. We get to that through the baggage compartment area. Our transponder antenna is off to the side right here,
And then our GPS and our ELT antenna, of course, is on top of the airplane.
Now on the back of the airplane on the top, here's our ELT, and it's just mounted right in the center. Now here's the track right here that holds the canopy. Open the canopy. So you can see the canopy, there's about an inch and a half between the canopy and the ELT, so it doesn't interfere when it opens. Now the GPS antenna is right here on top, just set offset of the track, and as you can see the canopy lifts up and over it when it opens, and then when it's closed, of course it clears it all together. Remember, with your GPS there is a front back and a side side. It is a directional type antenna, so that's how those are mounted. Now that we've got our antenna placement where we want them, and we've figured out the proper placement for them, the big job starts coming, and that's wiring. And not only just your antenna wiring, but all your electrical wiring and engine wiring, things like this. Wiring is not as big a problem as a lot of people would like to make it to be, if you know a few basic guidelines and rules and a few things to remember. One, that your grounding is just as important as your power. You know, if it calls for an 18 gauge power lead, use an 18 gauge ground lead, because the current flows from power to ground. Also on your engine, people will run a number 2 cable to their starter off of their starter relay, and they'll forget to ground their engine. And the engine is not grounded through those rubber mounts, so you have to run an engine ground, and we'll show you that here in a bit. The other thing about wiring, electrical wiring, and it's probably the thing that causes people the most problem, is not using the proper tools. A pair of needle nose pliers is not a crimp tool. You have to have 2 or 3 different types of tools depending on the type of connector you're using. Now, the connectors for your coax, like they'll be used on your antenna, and you can get some that have screw terminals, but now they've come out with connector terminals, and you have to get a special tool that crimps those on, and we'll do one here shortly. But you know, the jaws of this is made just for crimping it. If you try and use a pair of pliers or something, you're just fooling yourself. It's not going to work, and then when it fails, you're going to blame all this darn electrical systems. You know, you can't count on them. Well, you can count on them. The next thing is just your little ring terminals that you'll use to connectorize all your things, to put your wire connectors on. Again, people use diagonal pliers or something like that. From Radio Shack, you can buy a very cheap tool. In the center here, it has a place where you can cut bolts. In the back here is a stripping gauge and a stripper. And then these jaws right here are made just for crimping those O-rings. There's even a little cutter here. So you get the right tool. A couple bucks will save you a lot of problem. Now, a lot of your radios and all have a different type of connector, and this connector doesn't crush in, but actually curls in like this. And so you have to get a different tool, and these are available. And this has a series of different jaws, and they're not round. They actually have a crimp that it'll take the metal and curl it right in on itself. And that's what holds those little terminals. So that's the other tool you need to get. Also, eventually you're going to need to solder something. Get yourself a nice little pinpoint solder iron. You can get these from Radio Shack, so you don't have great big globs of solder. We talked about using the whisker antenna for both your glide slope and your VOR. Well, here's the little splitter you can get from Chief or Aircraft Spruce, and basically your antenna hooks here, and they're labeled. This is VOR here and glide slope here, and this will get mounted up under the instrument panel, and your antennas will run off from there. The other thing is your starter switch, and we'll
go through the starter switch here, and then we'll show you some different types of wiring connections. Your starter switch has a couple functions. One, it's used to start the engine. Well, when it starts the engine, most engines should start on the left mag. That's the mag that has your impulse coupler on it. So to stop any accidents, the right mag is shorted out. Now how that is shorted out, on the starter switch right here is where your right mag gets hooked to. And when it comes to you, there'll be another switch, and it'll be marked, or another terminal, and it's marked ground. And there's a little bar that you have to put in between those. If you don't put that bar in between there, when you turn your key to start, both mags will be hot. Right now, with the bar in there, when I turn the key to start, the right mag will ground out, so you only start on the left mag. Once you go to both, it releases it. The back of the switch, actually, you can't see it, but is marked. Your battery goes here, and that battery is just enough to start your starter solenoid. Of course, you've got ground here, and this ground is hooked to this ground internally. You got right mag, left mag, and an S, which is your starter solenoid, gets hooked there. So remember to put this little bar in, or you could end up having some problems starting on both mags. A lot of people worry about that happening, so they'll actually put in a switch where you can ground the right mag, but your starter switch should take care of that. Also, to protect your wire, you can get this little twist stuff, so you can protect bundles of wire. You can get a whole bunch of wires and you can wrap this around it, and it makes a real nice clean job. The thing you want to remember about wire and wiring is you want to take the stress off of the end of the wire. You don't want the wire to sit there and vibrate. And there's several ways to do this. You know, you can drill some holes and tie it, bundle your wires together, stops the vibration. On the antenna leads, if there's a connector here hooked to the antenna, we'll actually take a loop and put a wire tie right there, and that way the end of this can't vibrate. This is going on down through the bulkheads and on out. If not, the end of this can sit there and vibrate. It'll eventually just break it off. So we always put a little wire tie on there. Okay, first we're going to show you the different types of terminals and just how the tools are being used. Okay, we're going to start with the simplest connector, and that's the little ring terminals. First thing you want to do is strip your wire, and there's a couple different types of wire stripper, just to show you some. But the little tool that you get from Radio Shack you can use, and it's got a marking of the different gauges of wire. So you find the gauge that you're using, put it in there and just rotate it a little bit, pull it off. Now, the reason we don't use diagonal pliers is that this clips off just the little bit of the casing, the covering. Diagonal pliers, you do that, you'll nick the wires, and you end up not having as many wires as you think. Then you put it on, and I like to put it on until I can see just a little bit of the wire protruding out the end here. And then just a tiny little bit's coming out the end here. Then all you have to do is take your tool, and your tool's actually color-coded according to the color that's here. And we select the red one, and they tell you that you can use just one crimp, but two's better. So if you put the tool right up against the edge, okay, and squeeze and get one crimp there, and then move it back just a little bit and get another crimp, there you go. That's the proper way to put that on. That's not going to come off or vibrate loose on you anytime soon. The next kind of connection that you do with this wire, like I said, if you're wiring up your radios, are little pin terminals like this that'll slide inside a connector. And these are some little rascals. And they've got just a little piece on the back here. And these are the ones that curl in. So again, you strip your wire. Now these have two places where you can crimp. The forward one, I don't know if you can see this, the forward one catches the wire. The aft one will actually catch your insulation. So you don't strip off too much wire. You want that end wings to catch the white part of your wire. Then you get the right tool again, and like I said, you can find the size you need. Put it in there and crimp it. Now, what that did, I don't know if we can get you a shot of it, right in here. Now what this did, instead of just smashing down, like I said, it curled it in and locked it in. Next you have the end of the wire has two little wings that can be crimped on right here. And I find them, there's a couple ways you can do those. You can just bend them over, and they're plenty long. You can bend one over and then the other one over. And then there's a circular crimper in here. And we get the right one. And we catch that with the circular crimper. That now grabs the wire itself. And I guarantee you that connector will not come off. But it's all in using the right tool. Also, if you're going to be putting ends on, some people like to insulate them a little more, and that's with little heat shrink tubing. Now this tubing comes in different sizes, and the general rule is that the tubing will shrink to 1/2 its original size. Now a lot of people will use matches or something to shrink this. The best way to do it is with a hot gun. Okay, and you can just basically just get your hot gun. And that's all it took. You do it with matches, you're going to end up with burn marks, and sometimes it'll get too hot in one area and split it open. When that cools, that'll be permanent, and you got a nice insulator there. The next thing is coax cable. Like I said, that you can get the twist-on connectors, the kind that comes in halves and you split them and twist them on. I prefer the crimp-ons. The crimp-ons come with 3 parts: the main body, and you've got a little crimp ring, and then you've got your actual connector pin. These are easy to put on. First you put your crimp ring on, slide it down. Then on the package it gives you a little drawing and instructions on exactly how to strip the wire down to put it on. So by the instructions, we first take our outer casing off. And some of them are tough. Then the next thing we have is this shield. Now you look on the instructions and you only want about a 1/2 inch of this shield. So what you can do is take a small pair of plier cutters and strip it down all but that last 1/2 inch and cut it off. Now you want to pull that down out of the way for right now. So we just slide it down over it. Next thing is another layer of reflective metal, grounding metal, and this is just another shielding layer. And we want to take that off. And then we've got our center conductor. So we go ahead and, according to it, it gives you dimensions, how far to come up. And that leaves our center wire. And we'll give that a couple twists, and that only needs to be less than 1/4 inch long. Okay, now we're ready to start putting this thing together. First we put our center pin in. And we want to twist these center wires together. And it just slides right over it like that. And our tool has a very small crimp area just to crimp this pin on. So we put it on there, give it a squeeze. Now some of them, the ones that don't crimp on, have a little hole in there where you can drip solder through and solder it on. Once the center pin is on good and tight, we go ahead and slide our main body over it, and the pin will come up through the main body. It's down inside there. Slide our shielding back up over the main body. Bring our crimp ring up, just like that. Then we take our tool again, slide it all the way up to the top of the collar for our first crimp. Crimp it, move it down, crimp it, and we've got it. You may have some excess strands of shielding sticking out here, and you can just trim them off with a small pair of wire cutters. And our connector's on, good and tight. Now, my suggestion is everybody should have a volt-ohm-meter, especially if you're doing any kind of electrical work. At this point, take your volt-ohm-meter and go from the outside to your pin. You should read absolutely nothing. It should be dead open. And that's just to check to make sure that all it takes is one of these little strands to be in the wrong place, shorts it out between your center conductor, and the cable wouldn't be any good. So I would check, like I said, from the outside to your pin with a volt-ohm-meter. Now, like we were saying, what we do to take a little stress off the wire, when you hook this to an antenna and it sits there and vibrates, it could sit there and do this. We take a little loop, and once it's on, we'll take a wire tie and wire tie that together, and that takes the vibration out of the end of that. The last thing I want to show you on the antenna wires is we were talking about the little whisker antenna, and you got to make yourself a ballon to go on that. Now, some whisker antennas come with the ballons already in them, but you can make them, and all it takes is a piece of wire. Basically, you take a piece of antenna wire. Now, I don't have a big enough piece here to actually make a full-size one, and you take a bend. Now, from here to the bend should be 18 inches. Okay, and that's an important measurement. The first thing you do is you strip the end off. Pull your insulation off. Take your second shielding off. And that second shielding sometimes is difficult to find where it wraps. There it is. What you're trying to do is isolate the center conductor away from all shielding. Okay. After you do that, you take a little piece of heat shrink tubing and shrink on the end of there. So the very end is completely isolated. Save your strand shield because you'll need that later. Okay. So now we've got 18 inches from here to here. And we'll bend it like that. It'll eventually look like this, except 18 inches. Now we want to take a razor blade knife, and up on this bend, we want to very carefully split our casing open about 1.5 inches down on both sides. And you don't want to cut through your strand shield, you just want to split that casing open. Next, you want to go ahead and take the case off. Right there in the center. And actually, if you get Bob Knuckles' book, The Arrow Connection, he's got a real simple drawing in there. That's an excellent book and newsletter to subscribe to if you're serious about doing a nice electrical system. Okay, so now we've got the shield opened up, and what we want to do now is in the center of this, where it would actually be the very top of the curl, we want to cut the braid. Now you want to be very careful not to cut the center conductor or anything. You just want to cut the braid open. And this just takes a little patience. The braid's reasonably loose, so once you get it cut a little bit, you can get it. Okay, now your braid's cut. The next thing you want to do is actually undo your braid, because you want to save all this braid, and it's done real easy if you can get a small screwdriver or a pin or something, and you can start unlacing this braid. Once we've taken the braid and stripped it all out, we take and divide it into threes. Now some people just twist it all together. I like to divide it in threes and twist it together. Then I take the threes and braid it into, I guess, what's called a ponytail braid, the three braid, and that gives you a little bit stronger braid there. And you just braid it like you braid ponytails, just one over top the other. And like I said, you can just twist them all together, but I found this gives a little more strength to them, and that way you don't have just a bunch of wires twisted together, you've got them braided together. Then when you get up to about 1/4 inch of the end, then you can twist them all together, get your wire terminal, slide down over it till the wire starts coming up through the end there. Get your crimper, put your 2 crimps in. Alright, I've already done it to the other side. So here's what it looks like. Actually, it looks like that. On the antenna, on the radio end, you actually put your center conductor in there, and that's how it gets hooked to the radio. On the antenna end, you don't hook the center conductor to the radio, but you hook your braided shield to the antenna, one to each of the 2 whiskers. Now, down at the other end of your 18-inch piece, remember you've got the center conductor insulated, you want to strip out a little bit of the conductor off of the other piece and solder the 2 braids together. So down here at this end, the braids are soldered together, and up at this end you've got this, and this will all fit in, the 18-inch piece will all fit into the cap of an RV up on top of the vertical stabilizer. So that's the wiring that you need to do for your nav antenna. And don't ask me to explain how it works, because I don't, other than I know it works very well, but the physics and the principles behind it are far beyond me. I just do what works.